It's not a matter of if, it's a matter of when we have these catastrophic wildfires. Historically, this area has been burned for thousands and thousands of years. It's a fire-adapted ecosystem.
There were fires that were burning 100,000 acres fairly frequently throughout the Northeast, and especially in the New Jersey Pine Barrens. It's an area about the size of Rhode Island that's smack dab in the middle of the metropolitan area of New York, Philadelphia, not too far from Washington, D.C.
It's in the interest of public safety and the ecosystem in the area to have a good understanding of how we can have healthy prescribed fire in this landscape.
Prescribed burning it's the cheapest, most effective way to manage the land. We set the tone, we set the pace, we play the hand that we want.
The work that we're going to accomplish here today is going to help fire managers understand how a fire would burn through a real landscape.
Our focus here is around the embers or the firebrands that are generated from fires. These are the leading cause of ignitions of structures at the wildland urban interface.
Basically, during a fire, things like bark on a tree can come off because of the action of the fire, and they can be lofted by the wind and carried quite far depending on how the wind catches them, and then land while still burning or smoldering and cause an ignition.
It's not the 200-foot wall flames that you see that are going to get you. It's the embers that land quarter mile, half mile away and land in your gutters or on your roof.
It's an important part of fire spread that's not very well represented in our predictive tools and our models, even in our training.
We want to look at better ways of predicting the fire behavior. And to do that, we need to understand how many firebrands could be generated from a given stand of trees and a given fire behavior, and then try and relate that to where the firebrands are deposited.
We've been doing this for a long time, so we have a cache of equipment.
We have a sensor that measures wind, a sensor that measures the temperature and humidity. We've got sensors that measure where the fire line was, how it progressed through the fuels from start to finish.
We really just have kind of scant data out there from any sort of large or prescribed fire. Being able to collect more of that today is really exciting. It's going to give us a huge valuable resource to go away and analyze afterwards and try and characterize those in more detail, and to really link that to the fire behavior.
The diameter at breast height was 6.5 before, and now it's 6.3.
Silas Little is important because it's one of the only experimental forests that does fire behavior experiments in the field.
We've been coming here, University of Edinburgh team, for around 10 years.
There are only a couple of other places in the world where anything similar is really happening. Seeing these sort of experiments at this large scale is pretty unique.
We want this to come out as a head fire.
This research wouldn't be possible without the bipartisan infrastructure law, and the partnerships are the only way we get all this work done. We have the local New Jersey Forest Fire Service, the Regional Fire and Aviation Management, Department of Defense through its Strategic Environmental Research and Development Program, and its Eastern Innovation Landscape Network.
The work is also funded by NIST, the National Institute of Standards and Technology.
NIST tends to focus a lot more on the structural side and community side of things, and so we have a lot of facilities where we can look at buildings and how they would behave in a fire and how they can be hardened. But this affords us the opportunity to actually come out into the natural environment and understand how fire spreads.
It's really only by bringing the academic research and then the Forest Service research into the actual practice of doing things that lets us do what we're doing today.
This is like a really unique opportunity in the way it brings together people like across countries and across borders, as well as across disciplines.
The real benefit to the taxpayers is not just local even, but I would say it's more of a global benefit. Working together, we really can roll the ball forward scientifically to make the world safer for folks.